Hi guys, today's lesson in Algebra 2 is the discriminant. Discriminating minds want to know. What does it mean to discriminate? Well, to discriminate, it has a negative connotation in the English language today, but it really is a neutral word that means to differentiate between one thing and another. To be a discriminating shopper means you are an informed shopper that's able to distinguish between a good deal and a bad deal. So what the discriminant does is it allows us to determine how many x-intercepts a quadratic function will have. And you can see that it's part of a larger equation. This is a famous equation over here known as the quadratic formula. It looks a little daunting. We're not going to be working on all of that today. That'll be next time. We're only going to focus on a piece of it, and it really isn't as scary as it looks. Some of you may have worked with it before. You know what A, B, and C are in relation to a quadratic function in standard form, ax squared plus bx plus c. So all you have to do is replace the a and the b and the c with their actual numerical values in the equation. Then it's arithmetic. So we're going to do one piece of it today so that you're comfortable with this thing called the discriminant. And I will write that down now. So the discriminant, what happened to my black marker? It's not there. The discriminant is the piece of the quadratic formula that is under the radical. So under the square root symbol, it's simply b squared minus 4 times a times c. That is the discriminant. The reason that it helps us determine how many x-intercepts there are is because you'll notice it's, like I said, under a radical. We have to take the square root of whatever b squared minus 4ac comes out to. If b squared minus 4ac comes out to a positive number, no problem. The square root of a positive number is a positive number. If b squared minus 4ac comes out to 0, the square root of 0 has only one solution. It's 0. And you can see that little plus and minus over there in the formula. This guy here. Well, if we take some number and add 0, and we take some number and subtract 0, it's going to be the exact same number. Conversely, if we add a positive number and we subtract that same positive number, we're going to get two different answers. Okay, so if b squared minus 4ac is a positive number, we're going to get two solutions to that quadratic formula. If b squared minus 4ac is 0, we're going to get one solution. And if b squared minus 4ac comes out to a negative number, then we got a problem. We're trying to take the square root of a negative number. And that's not defined in mathematics, at least not with a real number. So in that case, there would be no solutions. So you can see how just determining what b squared minus 4ac is will help us determine how many x-intercepts there are. And don't forget that a quadratic, and we're going to get down into that, but let's just move on. And you'll be reminded of some things. Okay, so we're going to look at letter A. And letter A is a trinomial, x squared minus 6x plus 9 equals 0. Now, if I was solving this, oh darn, if I was solving this, I would not use the quadratic formula. Now, we're not trying to solve this today. We're simply finding the discriminant. But if I were trying to solve this, just for fun, so you know where we're at, I would factor. So I would take and factor the x squared minus 6x plus 9 into x and x, two things that multiply to 9 but add to negative 6. That's minus 3 minus 3. And the only solution to this one is 3. And so this one has one x-intercept, or one solution. But we don't have to do any of that. We don't have to go that far today. The only thing we're doing is determining how many x-intercepts it has. And to do that, we use a discriminant. Okay, the discriminant is b squared minus 4ac. So we need a and b and c in the discriminant. B is negative 6. So negative 6 squared, be careful putting that into the calculator if you need to, but you should know that negative 6 times negative 6 is a positive 36. Minus 4, 4 is always there, times a, in this case 1, times c, in this case 9. So negative 6 squared, positive 36, any squared number is positive, minus 4 times 1 times 9, and that is 36. And so the discriminant came out to 0. Can you take the square root of 0? Yes. The square root of 0 is just 0. So in the quadratic formula, we would then take the opposite of b plus or minus 0. It doesn't matter what the opposite of b is. When you add or subtract 0, you only get one answer. And as you can see, looking down at the graph of that equation, it does indeed have only one x-intercept. It's the vertex. Okay, let's try the next one. X squared plus 2 equals 0. All we're trying to do is determine the number of x-intercepts. What does that? The discriminant. So b squared minus 4ac. Well, this one has no b. It has a b of 0. A is 1, and c is 2, but there's no x term, so b equals 0. So b squared is 0 squared. I said 0 squared minus 4 times a is 1, and c is 2. Let's see what's going to happen here. We're going to have 0 minus a positive number, and that positive number is 4 times 1 times 2, or 8. And the discriminant says negative 8. Now that would be under the radical, so we're trying to take the square root of a negative number. The answer to this question is yes, you can take the square root of a negative number, but it gives you an imaginary number. So for our purposes, no, we cannot take the square root of a negative number. It does not produce a real number. And look down at the graph below, which is the graph of x squared plus 2. Recall that's just like the parent graph with a vertical shift up 2. It's never going to cross the x-axis, right? It's opening up with a vertex that's above the x-axis. So no x-intercepts for that one. So we've got one x-intercept with a vertex on the x-axis. We've got no x-intercepts. This one's probably going to be 2, right? X squared plus 4x plus 3. Well, if I were trying to solve for the x-intercepts, I would actually factor that. But let's just practice with the discriminant. B squared, B squared is 16, 4 squared, minus 4 times 1 times 3. That's 16 minus 4 times 1 times 3 is 12. And in this case, the discriminant is a positive value of 4. You can take the square root of a positive number. And you can see if we used, excuse me, if we put that 4 under the radical up here, and we took the square root of 4, which is 2, and we added 2 and subtracted 2 from whatever the opposite of b is, we would get 2 different answers. So this produces 2 different answers, and you can see indeed that the graph below shows 2 x-intercepts. And so we could have determined that from the discriminant. Okay? All right. Let's go to the next slide. This is going to be your practice. So I'd like you to practice these 4. All you need to do is, well, why don't we do the summary together, and then it might help you practice with these. So if the discriminant is 0, then 1. x-intercept. The discriminant is negative 0 x-intercepts, and if the discriminant is positive, 2 x-intercepts. You try these 4 problems. I'll make a key, and we'll get back to you in a minute. Okay, here's the key for those 4 problems. Recall, we are just trying to determine how many solutions. Not actually solving, just how many solutions we have here, okay? So, for the first one, how many solutions are there to that quadratic equation? I would use the discriminant to figure that out. So how many solutions? I'm thinking b squared minus 4ac. Okay, b is negative 12. I'm going to do this mentally. Negative 12 squared is 144. Minus 4 times a, which is 3, times c, which is 12. So 4 times 3 is 12. 12 times 12 is 144. We have 144 minus 144. That's 0. And therefore there is 1 solution to number 1. Number 2, b squared minus 4ac, the discriminant. b is 10. Some of you may find it helpful to label your a, b, and c right off the bat. a equals negative 1. b equals 10, and c equals 2. That might help you later, too, with the quadratic formula to put everything in the right place. So b squared is 10 squared, that's 100, minus 4 times negative 1 times 2. Now, this is the first case where a or c were negative, so you do have to be careful here. You have a couple choices when you deal with that minus 4 times a times c. You can treat the minus 4 as a negative 4 and do 100 plus 4. Negative 4 times negative 1. Negative 4 times 2 is, or sorry, negative 4 times, back it up. Negative 4 times negative 1 is 4 times 2 is 8. So we're actually adding 8. It'll be 108. Or you can say, I'm just going to leave that minus there as a minus. I'm going to treat the 4 as a positive 4. I'm going to do 4 times negative 1, which is negative 4, times 2, which is negative 8. You still get 100 plus 8. So you can think of it as a negative 4 being multiplied or minus a positive 4 being multiplied. Either way, you're going to get the same thing, addition in this case. And moral of the story, we have 108 for our discriminant. That's a positive number. That means there's 2 solutions. Better break these up a little bit. Okay, number 3. How many solutions are there? How many x-intercepts? Let's find out. B squared is 2 times 2, that's 4. Minus 4 times a, negative 11 times c, negative 9. Here we have a and c are both negative. So that means we're going to end up subtracting. So I'm going to do 4, and I'm going to think of this as negative 4 times negative 11. That's a positive 44. And positive 44 times negative 9 is minus. I don't really need to do out the multiplication here because I'm taking 4 minus a large positive number. 44 times 9 is 396. 396. And the result is negative, so none. No solutions. You can't take the square root of a negative number and get a real number. Okay, and finally, 3x squared plus 8x plus 1, that's going to be b squared is 8 squared, 64. Minus 4 times a is 3 times c is 1. All positive here, so no worries. That's 64 minus 12 and 52. So we get 2 solutions here. That's a positive number. Okay, so that's just b squared minus 4ac, working with the discriminant. We'll plug that into the quadratic formula next time. See ya.